Right, you may have a look. So are we ready for the next session? So welcome back to the concluding session of the 14th BITC of the Bengal Chamber. So this is a demonstration by the students of Narola Institute of Technology. The session would be moderated by Mr. Somnath Nag, Vice President Marketing Calsoft Inc. He has traveled from Bangalore to join us today. He is also a member of our IT committee, but he has made the effort of traveling from Bengaluru and joining us here. And the demonstration would be by Mr. Shoykot Choudhury. He's the team leader of this team who will be presenting here today. He's a second year student in the Electronics and Communication Engineering Department of Narola Institute of Technology. Mr. Obhik Dotto, second year student in Electronics and Communication Engineering Department. Mr. Obhinav Roy, second year student in Electronics and Communication Engineering Department. And their mentor is Mr. Obhijit Ghosh, assistant professor in the same department. So I would request them to be on dais and over to Mr. Somnath Nag. I would request the guests to please take their seats. And in case you would like to catch up, this room, the annex room is available. You may please have your discussions there, and otherwise you may please take your seats.
Good evening. I hope I am audible. Thanks for staying back till late for the last session for today here. So I think few last sessions that we have gone through today, there are a few interesting things where we are all talking about connected ecosystem, right? Now here, I think the students of NIT, they are going to demonstrate us something which is a real connected thing that when you think about. So we heard from today morning a lot about artificial intelligence. We have heard about connected ecosystems, robotics, right? Now I'm not saying they are going to do everything, but I think what they are bringing to here to show us something which is a connected vehicle, and which is more from a technology perspective is called telemetry. Use the data to, okay, I will not really get into the things. What I'm saying is that what they are doing, which is very useful for some of the cars, or most of the cars and most of the car drivers in future. I think I will just tell that and hand it over to them for their presentation.
Hello. Potholes. After hearing this word, this kind of picture pops in our mind. Potholes are those annoying road defects which caused lots of troubles, including damages, accidents, even accidents and deaths. Okay, so we are Team Potholder. We use technology to fight against these potholes. Good evening, ladies and gentlemen. This is our introduction. Firstly, we have developed an connected system. Basically, it's consists of hardware and software. Both connects together via a cloud, and it detects potholes and other types of road defects such as humps. Like there are a lot of accidents happens due to unmarked humps. And then there are some roads which are not maintained properly, so there are like a long road with like lot of stones and everything. So we fight against that. So this is our team. I am Saika Choudhury, the team lead.
I'm Avik Datta. I am the hardware enthusiast of the pothole team.
I'm Abhinav Roy. I have mainly focused on the data analysis part of this project.
We all are from Narula Institute of Technology's Electronics and Communication Department. And let's meet our mentor. She is Professor Dr. Shonda Patnaik ma'am, and he's Professor Abhijit Ghosh sir. Without them, this project shouldn't be alive, and today we wouldn't be here for presenting. Okay, so let's have the overview of our system first. Our system works on 4 stages. Firstly, we have a specialized hardware which identify the road irregularities, like if there is pothole or if there is some humps, unmarked humps. Then it also gets the location of the car, then it marks that location along with the severity of the defect in our server. Then onboard users and upcoming users can able to see those data in the app, and they get alerted, like we have to drive with caution because the ahead road is damaged or there is some issue in the ahead road. And then it also displays our alternate routes, and currently we are working on it.
Now let's come to the controller logic flow and system overview of our project. Firstly, let's come to the system overview. These are the 3 main hardwares we have used in our project: IMU sensor, vision sensor, and GPS, and all of them are connected to our MPU or microprocessor unit, and then it is connected to our cloud server through a communication gateway. Now let's come to a brief description of the hardwares we have used. Firstly, we have used IMU or inertial measurement unit. This is basically to measure the amount of jerk a vehicle has encountered while traveling. Okay? This will help us detecting the potholes and bumpers or some damaged roads it has encountered on its way. And this is especially useful when the vision sensor is blocked due to darkness or due to foggy weather, or sometimes when the pothole is covered with water in the season of monsoon or while it is raining. Now let's come to another hardware, that is vision sensor. This is basically a camera. Here we will identify potholes and bumpers with the help of vision sensing or object identification from the live camera feed. And now the last hardware, that is GPS. This is basically to locate or mark the potholes and bumpers on the map through our app.
Let's come to the hardware part. We basically use only the 4 components, that is a MCU, that is the microcontroller unit, IMU, the initial measurement unit, a camera, and a GPS only.
Now let's come to the mobile app. These are some pages of user interface on our app. Now, when you turn on the app, you will see this kind of page. Now here you can see it is showing good. That is because the surrounding road condition is good, as it can detect your location, so it will say according to the surrounding road condition. And when there is many potholes or bumpers or damaged roads around you, then it will definitely show a different comment. Now under that, you can see before that, you can see in the photo that there are different location marks of different colors. The red one detects the pothole, and the purples are for detecting bumps. And there is one more thing, we are still working on it, that is we are trying to mark the roads with damaged roads basically with the colored polylines according to the severity of damage of the roads. Now here in this page, under the good, you can see option report condition. Now when you click on the report condition, you will get 2 options, that is trip and spot. Trip is for while you are starting a trip, then click on the trip option, and this kind of page will appear. Here you can see different parameters like trip duration, speed, and potholes detected, coordinates, etc. And here this is basically to detect potholes and bumps when you are traveling. And after trip, you can end that. And after ending your trip, you will see this kind of page. This is basically gives you the summary of your whole trip, that is the trip duration, the distance traveled, number of potholes you have encountered, etc. Now let's come to another option, that is spot. Suppose you are not driving or you are not traveling, you are just roaming on an area and you have seen a few potholes or bumps. then what will you do? You will just capture a photo of that in our app and will upload that. After capturing, and you will see this kind of page which will also detect the location of that area. Okay, and we will also add this location to our map so that upcoming drivers or users, when they will go through that area, they will also be able to see this pothole or bumper, whatever.
Let's come to the development phase. There is some glimpse of our development phase that we are working on it.
Now let's come to the data visualization. Here you can see a graph. This is graph is basically made with the data we have got from the IMU sensor. Now here we will try to explain that how we will identify potholes and bumps with the help of IMU sensor data. Here you can see that when the graph is just rising and then falling, that is basically when you will encounter a bump. Because when you encounter a bump, you see that our car firstly rises, then it falls. So when you can see that his hand, he is holding the sensor, IMU sensor, that when his hand was like this, yes, just like this. This shows the bumper, and you can see in this graph, the graph is firstly falling, then it is rising. This occurs in case of potholes. You can see that car firstly go down and then it rises. So this helps in detecting potholes. And after that, if the IMU sensor continuously detect continuously detect a jerk, then we will then we will detect that as a bad road or damaged road on our map.
Okay, now we have also done image processing, like object identification, because see, always we will not purposefully go through a pothole or bumper, right? So sometimes we try to escape it, right? So in that case, that feed will not get recorded. So we will place one camera in the dashboard. It will check about the head road, how much we can capture, like field of view is maximum of like maybe around 10 to 20 meters with our current setup. We are thinking to expand it in future. So see, there is normal road, that's why it's showing normal. And whenever pothole is detected, it will show pothole, and this everything will be done on live, like live object recognition will be performed on the car.
Let's go to the test phase. We test our hardware in the Barakpur region in bike. You can see the hardware of our hardware. It's plugged in the mudguard of the bike.
And this test was made on a two-wheeler, and then we also performed the same test on a four-wheeler. And as you can see, we are getting live data. Then we compared with our like real-time situation. Then we are constantly training our model. Currently, we are not using any machine learning algorithm. Currently, we are using simple threshold values, but we are currently learning about the machine learning part, like how we can implement this data, because false triggers might occur, right? So we are trying to integrate the whole thing with a machine learning model. So this is the review while we perform the test on car, and as you can see that IMU sensor was placed on the dashboard. Okay, so I know majority of you are from business background, so let me come to the business side of our project. Okay, so we have main three mode of revenue generation. The first is from sales of our hardware. We are designing a hardware. We have already developed the first stage of our hardware, and we are constantly trying to make it better. Then we can get a portion of revenue from the subscription, like in-app subscription. Then the third thing is partnership. We can collaborate with different companies with our project, right? So from that we can earn a revenue. Let's have a detailed lookup of our revenue generation model. Firstly, subscription. See, who use our app, they can able to see normal surrounding potholes for free. But if somebody wants like some customized suggested routes, like it will be based on the vehicle's driver profile, okay? Suppose if you're having a 4-wheeler, it will suggest a different route. If you're having a 2-wheeler, it will suggest a different route based on your preferences. So that would be included in our subscription. Then the second is data licensing. The cars who are using our hardware, the pupils who are using our app, we will get constant data from them. We can license those data to third-party companies, like suppose I'm having a road condition data and somebody wants to do some development on the road. So we can license those data to those third-party companies, and we can obviously earn a good amount of revenue from that. Then third is partnership. We can have partnership with different logistic companies or delivery agents like Zomato, Swiggy, or we can have partnership with logistics companies like DTDC, Blue Dart or something. Because see, those drivers drive cars for transportation, right? And they obviously need to have a good idea about ahead road. And especially in night when they can't able to see and they going through NH or something, maybe there is some issues. So how they can able to know that? So our app will help them to drive with caution. Then the third is government tie-up. Fourth is government tie-up. We can have tie-up with governments, like when governments want to do development and maintenance, we can share the analytics data to them, which is obtained from our system. Then we integrated Prime features. This is just an add-on feature. This is not our main focus. This is just a side thing for getting little extra money. So what we included on the Prime features, that is like personalized alerts. Like suppose you want to go into a particular area and you want to get notified. So you can do that. Then one of my friends suggested me to add that historic facts. He loves to travel through different places and he always curious to know the history of that place. So we thought, okay, after a certain stage, we can integrate that. So somebody who paid for that feature, they can able to see the historical glimpses of that place while navigating, right? Then our hardware also can be connected with other systems, like suppose you want your car suspension to be an active suspension. Like while it's encountering a pothole, you want your car to automatically adjust the height of the suspension and minimize the vibration. So in that case, our hardware can be integrated with any other like suspension or active braking system, which is obviously done by higher-end car like BMW and all. They always use active suspension. So any existing user who are having normal cars, they obviously can integrate. So that's it. Once again, we are Team Potholder, a small step to make your journey safe. We are open to all the questions and suggestions. Thank you so much. Thank you.
But just few points I would like to ask you all. That you have said that you have primarily made your trials primarily on 2-wheeler, but 4-wheeler, what I understood, number of trials are not in that much of number.
Exactly.
And have you considered the different axles and traction for say 4-wheeler or 8-wheelers, 16-wheelers for trucks and buses?
Exactly. We need to get a proper stabilized prediction, we need obviously a lot of data. So currently we are doing experiments. We are doing experiments with different cars because our data always depends on the car, the vehicle's suspension also. Suppose a car having good suspension, obviously in that case we will get less vibration data. So constantly we are working like placing the hardware where the hardware can be placed to get the maximum smoothest data we can obtain. And then we are like doing other experiments also with different cars, and we are just currently getting the data and doing experiments. It's not been completed, that's why I don't have enough specific numbers, that's why I can't able to show you right now.
Yeah, great. And another point, in your financial model, you have practically shown all the possible options with government tie-up and the subscription and everything. But have you thought of any have you thought of any tie-up, or have you thought of approaching the car manufacturers?
Yeah, we thought it in second stage because firstly, we want a lot of data and we need a stable system. Then only we can approach to car manufacturers, right? Because if they see our system doesn't have enough data points or it can't able to predict that, so they might not accept us. So we thought firstly we will do like little testing, maybe with our own test vehicles, we will get enough data points, enough roads explored, then we can head towards collaborating with car manufacturers.
Yeah, but before you approach government, because government only they will recognize once this is vetted by the car manufacturers. Because today there are particularly for vehicles or private usage, there are a lot of safety features are already integrated. So your feature can be a boost for them as well, the OEMs and manufacturers. So
Sure.
you can harness that option also
Surely.
in a parallel route.
Surely.
And again, I am repeating that your concept is excellent, and you must be thinking of going for patent through
Yeah.
your institution.
Exactly.
This concept must be patented.
Exactly. Firstly, we need to develop algorithm. Like we are currently working on it, so we might file a provisional patent in within few months. Then we will, after development is completed, then we will go for the final patent.
And what is the development cost of the entire app?
App actually, as we are enthusiasts, we developed it ourselves. So currently we didn't face any development cost except that hosting cost of our cloud server. We have used here Google Firebase. So it's currently we are using the free version, but it might cost around 5,000 rupees for up to 1,000 users or 5,000 users. Yeah, 1,000 users basically. 5,000 rupees for 1,000 users for 1 year.
And the hardware cost?
Hardware, currently we are working on it. See, we will like to show you our prototype. Show the prototype.
This is the basic prototype.
Okay, so can you zoom? Okay, so this is the basically prototype, and Obik, just show the external attachment. Just wait a second. And this is the IMU sensor. As you can see, this is the IMU sensor. This is just a 1 inch by 1 inch size module. It can be placed anywhere in the car, and mainly preferred is dashboard. And this is basically the hardware. Okay. So these two are the hardware. So for this, the thing which we have developed, it costed around 2,500 rupees, but it having some limitations like that camera can't proceed higher FPS images. So it would be a bit difficult while the car is moving very fast. That's why we are thinking to upgrade the camera system, and we having an approximation that our final hardware will cost around 8,000 rupees, like that. Because it need to do live processing on the board. That's what.
Thank you.
Thank you so much. Any other questions?
I have a question. Are you processing the images live as we go on the road?
Exactly, we are processing the image live.
If that is the case, then you would need a very high availability of internet in even rural roads or any road. Is that possible?
Could you please repeat the question once
Like
again?
if you are processing the images live, then you would need high availability of internet even in rural roads, right?
Exactly. So what we are doing, we have just currently did one TensorFlow Lite model which can process offline. We have trained the model. It can get the data. It will process. If it got like pothole got detected, it will fetch the coordinates, like GPS coordinates, then it will send it to our server. And for that processing, we don't need any active internet connection. And suppose you can say like I went through a road where there was many potholes, but there were no internet connection. So those datas will be saved, and as soon as you connect to the internet back again, it will be updated. in our server. What? Yeah, currently we did on laptop, and we are trying to do on the ESP32 CAM, but it is quite like it's can't able to process the whole thing because of limited hardware capability. So we are constantly working on that to optimize the whole thing.
I had another question rather.
I think thanks for all the questions, but unfortunately we have to stop here, but you can always talk to them offline. But one thing I would like to really mention with my, probably 27 years of experience with working with the leading product companies in the world, both startups and the large, it is really heartening to see the few people from this in an engineering college coming out with this kind of idea, which is not just very simple. I think they need a big hand. And I really also appreciate the kind of questions that have come up, because that will help them to really think forward. Because, product development is just not such a simple thing. It's much complex than an application development. So product development perspective, I think the questions and the suggestions, I would suggest that if any one of you have any other questions, please, work with Angana and the team. Send it to them, any guidance, any suggestions, any idea on the business model, that will help them, motivate them to stay focused and they do things. So, absolutely.
Thank you, sir.
Thank you, sir. Thank you.
I think you guys have done a great job. Stay focused, but as I was telling you other day, find one reason why people will use your system. Not 5 reasons, one reason. And then your product will be successful. Thank you.
Thank you,
Thanks,
sir.
everybody. Bye.
Thank you. We are really happy that we have been able to conclude this year's BITC with such a promising session. And I would request Mr. Somnath Nag to please present tokens of appreciation to our speakers and their mentor on the dais. I would request Mr. Anindo Dash, VP Marketing Infinity Group and member of Bengal Chambers IT Committee, to please come to the dais and present token of our appreciation to Mr. Somnath Nag. But as I mentioned, Somnath is also our IT committee member, and we are really we really appreciate that he has come all the way from Bangalore and join us here. So this is our expression of gratitude to Somnath. So please enjoy the evening. Beer and kebab, I think it is already on. And please have your interaction with the speakers, with the students of NIT and also the other speakers offline. Thank you.